Hello everyone! Today I'm excited to introduce you to a tool that has become a game changer for diagnosing electronic components, the OctoTester. Whether you are troubleshooting circuits or just testing components for fun, this compact device makes this process simple, efficient and affordable. This right here is the OctoTester, powered by a USB, which could either be a USB port or it could also be a rechargeable USB battery. It comes with two probes that you'll use to test components. The device is designed to operate at a safe 3 volts, so you can test without fear of overloading or damaging your components. An important safety note is never to use this tester on energized or charged equipment, so please don't stick this into the main socket. Also, make sure capacitors are discharged before you test them, as it may lead to damage of the tester. The current version is 1.25 and this is what the tester looks like on the screen. Okay, so when you first powered up the tester, you'll see a horizontal line on the display. This indicates there is no connection between the probes, which is essentially an open circuit. This is one of the core features in the tester and is used for diagnosing faults such as broken tracks. It's also a good indicator that there is no continuity between 2 points. Moving on, when the probes are connected together, you'll see a vertical line appear on the display. This indicates a short circuit. This is another essential feature of the OctoTester. It is perfect for checking if components are shorted. Okay, now testing resistance. Here we have a 1 kilo ohm resistor. I'm going to place it into the breadboard because it will make for easier testing. With the 2 probes across the resistor, we get a diagonal line that appears on the tester. As you'll see, the closer the line is to horizontal, the higher the resistance, which means that the closer the line to the vertical, the lower the resistance. The perfect diagonal line, otherwise known as the reference value for version 1.25, is the 1k ohm resistor. Electronic circuits resistors don't commonly fail, but if they do, signs like discoloration or burning smell can indicate trouble. Often, when resistors burn out, it's due to an underrated wattage or another components causing an overload. I'm going to go ahead and test a range of resistance values to give you a better idea of how this works. I'm now going to show you the trace for a 100 ohm resistor. As you can see, the trace is nearer to a vertical line. This is a good indicator that the resistance is smaller than 1k. Next we'll go to a 10k ohm resistor. When testing across it, we see that the line is more horizontal. This is a good indicator that the resistance value is indeed greater than 1k ohms. Let me show you an example of the current limitation of version 1.25. This is a 100k ohm resistor. As you can see, when I put my probes across it, the horizontal line does not change. You can see a slight change at the ends of the trace. We will be looking at improving this in the future. Just for fun, here we have a 10 ohm resistor. As you can see, the trace for the 10 ohm resistor goes vertical, the opposite of the 100k ohm resistor. This is in fact another limitation of version 1.25. Allow me to show you why the OctoTester is so damn useful. Let me grab my big box of capacitors. Pick the 3.3 microfarad capacitor. As you can see, 3.3 microfarads. Okay, let's place it in the breadboard again. Let's go across the capacitor. It doesn't matter about the polarity of the probes. So what you see here is an oval trace. This is a good indicator of a healthy capacitor. So in version 1.25, the perfect oval is a reference value of 3.3 UF. This is a very important feature because it is very easy to diagnose capacitors. They are the most common components to fail, from reasons such as heat, ripple currents, or even age. Let's now grab the 47 microfarad capacitor from my box. Putting my probes across it, we can see that the oval has narrowed significantly, almost representing the short. You can imagine what happens as we increase the capacitance. Just to show you that, let me grab a 470 microfarad capacitor. Placing my probes across this one, we can see the trace is pretty much dead short. Let me just compare that by actually shorting my probes. This highlights the limitation of version 1.25. To show you the other way, Let's grab a 0.1 microfarad capacitor. Placing my probes across this one, we get a squashed oval, which is squashed more horizontally. You can guess what happens as you go down from the reference value. It will in fact shrink in the horizontal axis. A little bonus tip is that you can actually spot bad capacitors visually if you look at the top of the capacitor. If you see any domed tops, or even signs of the electrolyte leaking, it's a good indicator the capacitor's failed. As you see in version 1.25, can't get a trace for large capacitors. They are less likely to fail than smaller electrolytic capacitors. Here's the interesting part. This is a faulty capacitor trace. I've put a resistor in series to represent internal resistance that happens inside a capacitor when it goes faulty. Putting our probes across it, notice how the oval is now tilted. This is a strong indicator that there is internal resistance, meaning that the capacitor is likely faulty. The OctoTester can also test diodes. Okay, so here is my diode. I'm going to place it into the breadboard again. Probing across it, we will see we've got a spike here on the trace. This spike reveals the activation voltage for the diode, which is typically around 0.6 to 0.7 volts for standard silicon diodes, and this works for most diodes. However, when we get to Zener diodes, for example, the reverse voltage is often outside of the parameters of the OctoTester. The limitations of the current version 1.25 is 1.5 volts. What this means is that the Zener diode has to have a maximum of 1.5 volts reverse, otherwise the tester will not show it. This trace quickly diagnoses the state of the diode. A faulty diode either shows short circuit or an open circuit. Transistors. Here we have a 222A NPN transistor. I'm going to place it into the breadboard for ease of probing. So what we've got here is we've got the further left pin is the emitter, the front leg of the transistor is the base, and the back leg of the transistor is a collector. By placing our black lead on the emitter and our red lead on base, you'll see this trace. This is a good indicator that the transistor is healthy, and then if we probe from the base to collector, we should also get a similar trace. Notice that if we swap our probes around, this trace will essentially flip over to the other side. You may ask, why do we have a diode trace, or what looks like a diode? If we pull up a circuit diagram for a transistor, you may see an illustrated diode. So testing from base to emitter, we get the diode trace. From this, you can actually tell if the transistor is NPN or PNP, depending on where the spike is. Okay, with the basics out of the way, I'm now going to show you a more complex scenario. If we return to our capacitor and resistor setup, I'm now going to put a diode across both the resistor and the capacitor. And when we probe across this diode, notice what happens to the trace. Now we have a more deformed trace with a little flick at the top. So that little flick is actually the diode playing a role in the overall trace. When you see traces like this, bear in mind there may be more components at play here, and if needed, desolder the component from the circuit board to get a clean trace. Before we wrap up, let's just underline the limitations of the version 1.25. So the reference values for capacitance and resistance are fixed, so they are best suited for diagnosing and testing typical components. In addition, this tester isn't suited for testing big capacitance values and capacitors that are charged. So it's best to always double check the size of the capacitor if you're getting a funny reading. This applies for the resistance value as well. And that's the OctoTester. Whether you're a hobbyist or a professional, this little device packs a punch. If you found this video helpful, give it a thumbs up, and don't forget to subscribe for more tips and tools to level up your electronic game. Thanks for watching, and I'll see you next time. Bye.